Assalamualaikum, dear students. Today we are going to discuss the properties of the sulfuric acid. The first is physical properties. Sulfuric acid is a colorless, viscous, heavy liquid. Having density 1.84 grams per liter at 298 केल्विन. तो इसकी डेंसिटी जो है वो 1.84 ग्राम्स पर लीटर है. ये जो सल्फ्यूरिक एसिड जो है ये it boils at a temperature of it freezes at a temperature of 283.4 Kelvin and boils at 590 Kelvin. The high viscosity and boiling point of H2SO4 is due to hydrogen bonding which exists in this H2SO4. ये जो इसकी viscosity है या इसका high boiling point है, this arises due to the hydrogen bonding that occurs in the sulfuric acid. These are some of the physical properties of the sulfuric acid, and also it fumes in moist air. Now we have chemical properties. Number first is decomposition. This sulfuric acid is quite stable, but on heating it decomposes, liberating SO3. So H2SO4, when it is heated, on heating it forms H2O plus SO3. This is how it decomposes on heating. Number second is acidic nature, or the properties due to the acids. This sulfuric acid is a strong dibasic acid. So in the solution it ionizes, liberating ions of H positive, SO4 negative and HSO4 negative ions. So we will show H2SO4. In the solution it ionizes, it gives HSO4 plus H positive. This HSO4 bisulfate, it decomposes and it forms H positive plus SO4 2 negative. So in the solution form, this sulfuric acid gives all the reactions due to the formation of the hydrogen ions, sulfate ions and bisulfate ions. Now the reaction is due to the hydrogen ions, that is acidic properties of this sulfuric acid. Now the reaction is due to the hydrogen ions. We are discussing the acidic reactions of the sulfuric acid. The reactions due to the hydrogen ions. Due to the liberation of the hydrogen ions in the solution, it gives all the H2SO4 gives all the reactions common to acids. For example, fats with H2SO4 with the sodium hydroxide, the bases, it forms NaHSO4, NaHSO4 plus water. Or this sulfuric acid, when it is treated with the X of the sodium hydroxide, it forms sodium sulfate, Na2SO4 plus H2O, twice Na2SO4 plus twice water. Or it reacts with the sodium carbonate or with the sodium bicarbonate, Na2SO4, Na2CO3. It forms Na2SO4. This is sodium sulfate. And this is sodium bisulfate. So when the sulfuric acid, when H2SO4 is treated with the sodium carbonate, these are the acidic reactions of the sulfuric acid that are formed due to the liberation of the hydrogen ions. It forms Na2SO4 sodium sulfate plus H2O plus carbon dioxide liberated. Or if you take sulfuric acid H2SO4 with sodium bicarbonate NaHCO3, it again forms sodium sulfate Na2SO4 plus twice H2O plus twice CO2. These are the simple reactions, so you can balance them. Now we will see this reaction whether it is balanced or not. Sodium, though sodium 2, hydrogen 2 and 2, 4, hydrogen 4, carbon 2, twice we are taking sodium bicarbonate. So carbon is 2 here on the right hand side, so we have 2 carbons, the oxygen, 2 2s are 4, 2s are 6, 6 and 4, 10. 2 3s are 6, 6 and 4, 10. So these are the reactions due to the hydrogen that, or they are the acidic reactions of the sulfuric acid. Reaction is due to the sulfate ion. Next is reactions due to sulfate ions. Sulfuric acid, it forms white precipitate with the soluble salts of metals like barium, calcium, lead, etc. And it reacts with them and it forms the white precipitate. Sulfuric acid forms the white precipitate, and that white precipitate is due to the metal sulfate, due to the formation of corresponding metal sulfates. फॉर एग्जाम्पल अगर हम बेरियम क्लोराइड लेंगे BCl2, it reacts with the H2SO4, it forms barium sulfate BaSO4 and the acid is formed HCl twice. The white precipitate of barium sulfate is formed Similarly, if we take lead chloride or we will take lead acetate CH3COO whole twice Pb and allow it to react with H2SO4, this is the salt of the soluble salt of the lead, it reacts with sulfuric acid, forms lead sulfate. The white precipitate is due to the formation of lead sulfate. So it forms PbSO4 plus CH3COOH twice. CH3COOH, the reaction is balanced and the white precipitate is due to the formation of lead sulfate. Similarly, if we take calcium chloride and allow it to react with the sulfuric acid, it forms CaCl2 plus H2 plus HCl twice. So this is the white precipitate. Of calcium chloride. Here it was the white precipitate of barium sulfate. White precipitate due to the formation of lead sulfate. Here this is the white precipitate due to the formation of calcium chloride. Now the next property is that chemical property is affinity for water. Sulfuric acid has a very strong affinity for water. That is, next is affinity for water. This sulfuric acid has a very strong affinity for water, therefore it acts H2SO4 has strong affinity for water, therefore it acts as a very good good dehydrating agent. For example, it reacts with water and absorbs the water, plus water, it forms H2SO4 monohydrate, or it reacts again, absorbs the water, it forms dihydrated H2SO4. Charring of the sugar, charring of sugar is due to dehydration by H2SO4. For example, C12H22O11. When H2SO4 is treated with it, the sugar gets charred and black coal is formed. That is, we get H2SO4 11 times water. We have 11 times water, H2O. 11 2s are 22, 11 oxygen, 11 oxygen. Now we have 12. See, this is charred carbon charcoal, black charcoal. And if we take oxalic acid or formic acid with the sulfuric acid, formic acid with the formic acid, it forms H2SO4, it forms H2SO4, water plus carbon monoxide, H2O plus carbon monoxide, or we can show this reaction like this, HCOH, this is H2SO4, and it forms H2O plus carbon monoxide. And if we take oxalic acid, COH whole twice, and allow it to treat with H2SO4, it forms H2SO4 twice water. Now when this is HCOH, and we get twice water and carbon monoxide plus CO2. If we see COH, this is H2O and H2O, H2O, then we have COO, C double bond O, twice H2O, 2 times, and carbon monoxide, and we have H2SO4 plus H2O plus this is this COH, C double bond O, OH, C double bond O, OH, this is H2O, H2O plus CO plus CO2 plus CO2, because we have 4 times oxygen, 2, 3, 4, carbon 2, hydrogen 2, carbon 2, hydrogen 2. Now the next reaction is this sulfuric acid you have, it acts as an mild strong oxidizing agent due to the liberation of nascent oxygen. So we have oxidizing properties of sulfuric acid. It acts oxidizing properties. It acts as a mild, strong oxidizing agent due to liberation of nascent oxygen on decomposition in solution. So when we take H2SO4, it gives SO2 plus H2O plus nascent oxygen. It is because of the liberation of the nascent oxygen, it acts as an oxidizing agent and it oxidizes hydrogen sulfide to sulfur. So we have the reaction H2SO4 gives SO2 plus H2O plus O. Now H2S plus O gives H2O plus S. Now the overall reaction will be this and this cancel. H2SO4 plus H2S forms SO2 plus twice water plus S. Next is it oxidizes sulfur to sulfur dioxide. Now again the reaction H2SO4 gives H2O plus SO2 plus O. S plus O gives, here we have sulfur. When we take it is in the form of S8. Now we will take 16 times, it will form SO2. Here again we will take 16 times. So here we have 8 times. The overall reaction will be, ये oxygen cancel, H2SO4 16 times plus S8 gives, this is 16 times H2O plus 16 and 8, 24 times SO2 plus SO2. Next is it oxidizes carbon dioxide. H2SO4 gives H2O plus SO2 plus O. Carbon plus O gives CO2. We take 2 times carbon, we will multiply it by 2 such that the oxygen and oxygen cancels. We have to multiply the whole reaction by 2 so that we have 2 nascent oxygens liberated which then react with the carbon and form carbon dioxide. Now the overall reaction is, when we multiply the reaction by 2, the overall reaction will become twice H2SO4 plus carbon gives twice H2O plus twice SO2 plus CO2. These are the sum, and one more is that it converts phosphorus into phosphoric acid. Phosphorus is oxidized to phosphoric acid. P4, well, first we have H2SO4. On decomposition in the solution, it forms H2O plus SO2 plus O. P4 plus O gives P4O10, that is phosphorus pentoxide. This is dimer of the phosphorus pentoxide. This is 10 times oxygen. Now we have P4O10 plus H2SO4. Now, when the phosphorus pentoxide reacts with the H2SO4, it forms H3PO4. Sorry, when it reacts with the water, it forms H3PO4. H3PO4 3 times, 6 times. We have 4 times here. Now, what hydrogen we have 12 times, now 6 times, 12 times, then oxygen we have 10 times, 16 times, 4, 16 times. Now first the phosphorus pentoxide is formed, and at the same time this in the aqueous solution it forms phosphoric acid. Now the overall reaction is that we have to multiply it by 10, so that 10 times oxygen and oxygen will cancel. Now this and P4 is 1 times, it will also cancel. Now H2SO4 10 times plus P4 plus 6 times water forms, here we have 6 times water and here we have 10 times water. 6 and 6 will cancel, here it will remain 4 times water, 4 times water plus 10 times SO2 plus 4 times H3PO4, this is phosphoric acid. Now here in the reaction, sulphuric acid first reacts with it decomposes, forming sulfur dioxide and the nascent oxygen. Then this phosphorus reacts with the oxygen, forms phosphorus pentoxide. Phosphorus pentoxide with the water forms phosphoric acid. Now the overall reaction will be here. We have 10 times nascent oxygen. We have to multiply the first equation by 10 so that oxygen and oxygen will cancel. And in the third reaction we have phosphorus pentoxide reacting with the water forming H3PO4. This is 1 time. In the reactant side P4O10, product side P4O10, they will cancel, and then we will have the overall reaction. This reaction we have to multiply by 10 both sides. 10 times H2SO4 plus P4 gives, it will give us plus, here we have 6 times, but on the right side, product side, we have 10 times. So 10 times means 6 times water plus 4 times. 6 times water will cancel on both sides. Now on the product side we have 4 times water plus 10 times SO2 plus 4 times H3PO4, that is phosphoric acid. Now it is last oxidizing reaction is that it hydrogen acetate, it oxidizes hydrogen acetate to hydrogen. For example, we will take HBr plus H2SO4 gives H2O plus SO2 plus O. HBr plus O forms H2O plus Br2. So when the halogen acid is combined with this sulfuric acid, it liberates the halogens. So bromine is liberated here, it forms H2SO4. So HBr reacts with this, it forms H2O plus Br2. The overall reaction will be that H2SO4 plus HBr twice forms H2O twice plus SO2 plus bromine. So these are some of the oxidizing properties of the sulfuric acid. Now further reactions we will take in next lecture. Thank you.